Good afternoon. This is Andrew Wetham here from Information Management Group, continuing our series of webinars on new features of SQL Server 2014, and I'm going to be talking today about ColumnStore Indexes. If you have any questions, please type them in the questions box on your screen. I will have a look at them at the end. I probably won't answer them during the talk, but please feel free to file the questions at any time and we'll get to them if we have time at the end. If you'd like a copy of the slides and code, please email events@imgroup.com. That address will be up at the end of the presentation as well. I hope everybody can see everything. We had a little hiccup with screen resolution, but I think it's okay now. And so without any further ado, I will proceed. So I'm Andrew Wetham, currently Senior Consultant with Information Management Group, formerly at 3M Capital One. And I work for Information Management Group. And I think you've probably seen this slide before if you've been an attendee of these sessions. So this is what we're going to talk about today, ColumnStore Indexes. An introduction, a little bit about non-clustered ColumnStore Indexes, some more about clustered ColumnStore Indexes, excuse me, getting my tongue tied up, and if we've time, a little bit more. So first of all, a little background, brief introduction, just to make sure we understand what we're talking about. So the background is ColumnStore Indexes were introduced with SQL Server 2012, enhanced with SQL Server 2014, and they're part of Xvelocity, which is a new in-memory family. Well, it was new in SQL Server 2008 R2 when it was introduced with Excel and SharePoint, extended in 2012 with Analysis Services Tabular Model and ColumnStore Indexes, and now further enhanced in 2014. ColumnStore Indexes are designed to use modern hardware, and that means lots of cores and lots of RAM. So first of all, I just want to talk very briefly about a normal B-tree index. So this is what SQL Server will use most of the time. If you create a normal index, clustered or non-clustered, it will use a B-tree index. And the way this works is when you issue a query, the engine goes first of all to the root page. It will be directed from there to a non-leaf page, and from there down to the leaf page, which contains the data that you're looking for. A ColumnStore index is completely different. The data is stored in columns instead of in rows, and each column is broken up into segments. The segments are just over 1 million rows, and those segments for the same rows, the columns that comprise the first 1 million rows, are in a row group for the first 1 million rows. So the ColumnStore index is broken into columns. Each column is broken up into segments, and across all the columns, the equivalent segments comprise a row group. The data is then encoded and compressed, and ColumnStore compression is highly efficient. So how they work, they're highly compressed using dictionary compression. Each column is kept in a separate group of data pages. So that means that only queried columns need to be read, and only frequently accessed columns take space in memory. The clustered B-tree index or heap, where there is one, and we'll talk a little bit about that later, is only used to build the non-clustered ColumnStore index, and then it's paged out of memory. You can't have a clustered index with a clustered ColumnStore. You can't have a clustered B-tree index, obviously, with a clustered ColumnStore index. Each column is divided into segments of 1,048,576 rows, and that number is 1,024 squared, for those who are interested in why they pick that. ColumnStore indexes use batch processing to generate parallel query plans most of the time. And they use column and segment elimination to speed up queries. So the query optimizer checks filter conditions against metadata. So a little bit more about that. ColumnStore dictionaries are used for long strings. The strings are stored in the dictionary, and reference numbers are used in the column store itself for lookup purposes. So that it's just a number in the column store and that looks up a value in a dictionary. And that's most efficient with low selectivity, where you get the same strings being repeated lots of times. Column elimination works like this. If we issue a query, in this case from the InventoryWorks database, select some sales amount from Fact Internet Sales, we're only looking at one column, the sales amount column, and so data will only be retrieved for that column. All the other columns will be completely ignored. So that's different to a B-tree index, where the data for the entire row needs to be read from the disk. Segment elimination can be used as well. So in this case, we have the same query as the previous slide, but now filtering by year. So in this case, if assuming that all the 2006 data is stored in one segment, the other segments can be eliminated too. So we're only actually reading the segment which contains the data we're after. So, fantastic. Should we use them for everything? Well, there are a few limitations, and I'm going to go through some of the SQL Server 2012 limitations first, and maybe that will become clear why I've done that in a second. So in 2012, ColumnStore indexes are read-only and non-clustered. There's a maximum of one ColumnStore index per table, and that hasn't changed. All the key columns in a clustered index must be included in the ColumnStore. That's a non-clustered ColumnStore index. And they're only available in Enterprise Edition. There are some data types which can't be included in a ColumnStore index, and there's a maximum of 1,024 columns per index. So I hope that you don't ever need to think about whether you've reached that limit or not, because that's rather a lot of columns. There are quite a few other limitations as well, but these are the ones that I want to mention right now. So in SQL Server 2014, we're told that we now have clustered column store indexes and we have updatable column store indexes. So, wow, some of the major limitations look like they've been lifted. That's right, isn't it? Well, let's have a look. Starting with non-clustered column store indexes, and I'm going to do a little demo. So here we have a table which I've created beforehand, populated it. It looks like this. There are 5 columns there, some dates, some numbers, some text. And I'm going to insert a row because they're now updatable, right? Well, actually, non-clustered column store indexes are not updatable unless we disable the index. And then we can insert. And if we do a select, that's returned. I've done that quite quickly. It took 7 seconds when I set this up. So then, but our index is disabled. We can't use it. We can still query the table, but we're not using the column store index. So now if I rebuild this index, which will take a few seconds, somewhere between 15 and 20 seconds, we should be able to query and use the index, the column store index. So what I'm going to run here is this query, which is actually it's a seek query, which is not what column store indexes are good at. It's not what they're designed for. So there we've got our record which we've inserted. And we can just have a look now. I'm going to show you this system view, which is new, the ColumnStore row groups system view, which is not there in 2012 but is there in 2014. So that gives us 13 records here, one for each row group, and we've got the row group ID column there, 0 based. So we've got 13 row groups there, and somewhere in amongst that we have our record that we inserted. So how about a delete? Well, that's exactly the same. We've got our index enabled, so we can't delete If I disable the index, I now can delete, and I'll rebuild that. And I'll leave it to get on with that while we go back to here. So, non-clustered column store indexes in SQL Server 2014 are still read-only, and most of the SQL Server 2012 limitations still remain. So I felt a little bit put out when I discovered this, because I thought the hype had told me that they were now read-write. Well, clustered column store indexes are, but the non-clustered column store indexes are not. So let's now have a look at clustered column store indexes. Updatable. We can insert, update, and delete. In memory, which to be fair, the non-clustered were as well. Clustered column store indexes are the primary storage method for the table, which is what you'd expect. It must be the only index on the table, so I can't have any other index there at all. So that's got some implications for how we use this. And the clustered column store index does not store the data in a sorted order. So that seems, to anybody who's grown up with SQL Server and clustered, non-clustered indexes, this seems very counterintuitive, but that's how it's done. But we can do data modification. Records can be inserted, updated, and deleted, but the column store itself is only affected when a row group is full. So if you remember from the background, a row group is a collection of segments, each containing 1,048,576 rows. So if the row group's full, then it's moved into the column store, or if the index is rebuilt. Most of the time, any changes happen in two things called the delta store and the delete bitmap. So inserts go into the delta store and deletes are marked in the delete bitmap, and an update consists of both an insert and a delete. It's all managed behind the scenes. You don't need to know it's there, but it does have performance implications because column store indexes are good at scan operations, whereas B-tree indexes are good at seek operations. So the column store is not very efficient for seeks, but it is good for scans. The delete bitmap is actually a B-tree index. So that's good for seeks, but not for scans. The delta store is not indexed at all. That's just, in effect, a heap, I think. So the thing that we might use the column store index for, which is large scan operations, are not going to be efficient with either the delta store or the delete bitmap. A little bit more about these. The delta store is used to store new records until the row group is full. When the threshold is reached, the delta store is closed, each segment is compressed, and then the compressed segments are moved into a column store row group. And there's a process called the tuple mover process which does this. It runs every 5 minutes and picks up any compressed segments and moves them into the row group. So it's only used with clustered column store indexes, which is why the non-clustered are not updatable. And there can be multiple data stores for a clustered column store index. It's not used for bulk loading. So if you do bulk loading, you'll bypass the delta store, which may be quite a big advantage. Then let's have a quick look at a delete bitmap. This is a B-tree index that stores information about deleted rows. So when a record's deleted, it's added to the delete bitmap, but nothing is removed from the column store row group until the index is rebuilt. Not even the tuple mover process removes a deleted record from the column store row group. It's just marked as deleted. However, if a record is in the delta store, so if you've inserted a record and it's gone into the delta store, it's not yet being compressed and added to the column store, and then we update or delete that record, It does not use the delete bitmap. It can modify that directly. So the column store itself is still read only. So that doesn't get modified unless we rebuild or unless the tuple mover process comes along and adds a compressed and closed row group. So summary of the DML operations with ColumnStore indexes. Row groups are not immediately affected. Inserts are added to the delta store. Deletes are marked in the delete bitmap. An update is a combination of a delete and an insert. And bulk loading will bypass the delta store. A few more clustered column store index features before we have a quick look at them. They cannot have primary keys or unique constraints, so that's quite a significant restriction as well. There are no key columns. All columns are included. Some data types are not allowed. And now let's have a quick look. So I move to my clustered demo. And so I've got a table which is identical to the table we had before. It's just got a clustered column store index on it instead of a non-clustered. So let's have a little bit of information. We've got some row counts here. So you see we've got 11.75 million records in there. And this is our ColumnStore row groups view again. So once more, there are 13 row groups. Let's insert some records. So now, without disabling the index, we can insert some records, and I've inserted 5 here. And so if we do our select, we can see those 5. And now let's have a look at the row groups view. We can now see, looking at down the row group ID column, we've got a new row group. We see that this has a delta store Hobbit ID, the others don't. It's in a state of 1, open, whereas the others are in state of 3, compressed. And it contains 5 rows. So it contains our 5 new rows, and that's the delta store. If we were to reorganize the index, it makes no difference. So we just have a look at this. Still exactly the same. If we rebuild the index, again, this will take a few seconds. This time, our row groups will be reorganized. Those that were full will just remain as they are, but there's a bit of reorganization goes on, and our single record is going to be moved into one of the compressed row groups. So that has finished. So now we can see we're back to 13 row groups. Everything's looking hunky-dory. So if we do a delete now, so we're going to delete the record that I inserted before, or the 5 records, sorry. And now we'll see we've still got 13 row groups here, but this one, row group 11, has now got 5 deleted rows. So that's the delete bitmap has come into operation. And then if we rebuild that, those deleted rows will be actually taken out. So I'm going to skip that because it takes a little while. So what I'm going to do here is insert 2 million records. And this is actually not too slow. At least it wasn't when I tried it the other day. So what we should see here, we've inserted 2 million, which is more than the 1 and a bit million that a row group contains. And we see we've now got 15 row groups, because we're zero based. We've got 1 row group here, which is open, and that's got 951,000 rows in it. we've got one row group which is closed, and that's got the 1,048,576, and all the others are compressed. Now if we wait 5 minutes, the tuple mover process will come along and grab this one and compress it. Well, I'm not going to do that because 5 minutes is too long in the context of this talk. So if I were to delete all of those 2 million records, what do we think will happen here? So if you remember, we said that anything which is in a Delta store is not marked as deleted, it can be simply deleted. Whereas anything which is in a column store needs to be marked for deletion until we rebuild the index. So this query has now finished. And there we go. So we see these two Delta store row groups are still there, still closed and open respectively, but total rows is now 0. We've still got our 5 deleted rows from the first insert, and they haven't been removed. So let's just do a rebuild, and that will remove those other things. Okay. So just a few seconds to go, I think. Hopefully we should be there very quickly. Yep, there we are. And so now, if we have a look at our ColumnStore row groups, we're back to 13 row groups with no deleted rows. And I think that it's probably about time just to wind down. So does anyone have any questions? I have quite a bit more information I could go through, but we're 25 minutes into the talk, so just to allow time for some questions, we can do that now. And also a reminder that if you want a copy of the slides and the code, please email events@imgroup.com. Any questions, anyone? It would appear not. Okay, well, it remains for me to say thank you very much for attending. I hope you got something out of it, and I look forward to hearing from you at some point in the future. Thank you. Bye-bye.